Software project estimation. We are not talking about computation or any mathematical formula that is already been established. We are talking about estimation. So in order to achieve reliable cost and effort estimate, there are certain options for these software projects. First thing we can do is we can wait until the project is finished or complete, and then we can estimate. The second thing is similar projects which have already completed successfully, we can base our estimates on those projects. This project, last project, this much cost, this project, this much cost, like that. And we can use simple decomposition techniques for estimating the project cost and effort. Decomposition is all about thinking the project as a big part and dividing the sub part and then finding out the cost and effort for all of them and combining them. Or we can use the empirical models for software cost and effort estimation, that is already established certain formula or expression that has come from previous past you can say experience or results. The first is not practical. Why? Until the project is complete, after project is complete, then you decide to estimate. There is no point. Second option, because most of the time the past experience will not give you that kind of indication or good result that you can apply and tell for the present project. Most of the time it happens. I'm not saying it always, but we cannot rely always upon the similar project to give us the cost and estimate. So we will use the simple decomposition technique kind of way or the empirical models. So decomposition is all about dividing and conquering. That is, we assume the project as to be say a idea or a form of problem solving. So it's a big problem and we are solving it. So too complex, we cannot consider it. So we have to divide it into different pieces. That is, we will divide or decompose a project into major functions, sub-functions, all the related software engineering activities, and then we will try to estimate, and then finally we'll do it in a stepwise manner. The empirical estimation, the fourth point, is actually helping, complementing the decomposition techniques. A model is based on experience, historical data. So what all model we can find out is a simple function. That is, one thing is function of another thing. That is, we are saying the cost or the effort or the time. This is the function of what? This is the function. For example, this D. D is a variable. This is dependent on V, the function of V. So the cost, the effort, the project duration, all these is dependent on which factor. Just assume Y equals Fx. So Y here is all these three, and this X is nothing but the LOC or FP. That is, we can select the independent parameter. That is, you can give process, you can give the use case or the line of codes or the function point. So we'll talk about all these, mainly the LOCs and FPs. So we have decomposition techniques. First we do the sizing and then we'll do estimation. We can use use cases, and finally the problem based estimation, as you just found out, D equal FVI is based on LOC or FP and other parameters also. So there are cost estimation models like the empirical estimation technique, heuristic technique, and the analytical estimation techniques. These are the basic cost estimation models. I will see all of them, whichever is possible in this discussion. So project estimation is a problem solving, and then we assume it to be too complex. We decompose the problem, because why I'm telling you again and again, because until you divide it properly in terms of a line of code, in terms of function point, the project planner has to understand that when the scope is decided, the next part is sizing, and sizing comes from line of code and function points only. So the decomposition is the basic parameter here.